we have super cool inventors. Dr. Patricia Bath, she invented a tool for eye surgery. Madam C.J. Walker invented a line of hair care products for Black women, which was like the first of their kind. Just as a side note, she's also the first she's considered the first Black female millionaire, which is pretty cool for those of us like, who want to make money. And then Luis von Ahn, he invented Duolingo for those of you trying to learn Aramaic or Arabic. Or if you're, just trying to learn, another language like me. And then he also, if you've ever, this is like a funny thing, he also invented those little checkboxes that are like, I'm not a robot or whatever. Those little checkboxes you have to check when you're logging into stuff, kind of annoying. But this dude is the one you have to blame for those. So it helps to make like the internet a little safer though. So pretty cool. Some cool inventions happening. So shout out to Nayeli, Cameron, and Adrian who have birthdays this weekend. So hopefully that will be awesome for them. Cool. We have a low-key day today. We're going to do some announcements, some housekeeping, and then we're going to do Notice Wonder and then take notes and hopefully get to our assignment. And we'll make that happen. So housekeeping-wise, I've been noticing some things. One is that I really appreciate the people who are making their pictures like small enough to see, but big enough to see, if you know what I mean. This is a little bit harder for me. So you might notice if I was grading your assignments, sometimes I click on them and I make them a little bigger. It would be really, really awesome if in the yellow box, the picture fits inside the yellow box just like this. So it's not like going over the side. It's not really big. You can click on it and then drag it to the size that you want it to be. So maybe not so like miniature and small, but actually like this size, that would be super duper awesome. That's just like, if you don't want to do that, that's fine, but that'd be better for me. So that'd be cool. Thank you. Okay, let's talk about Tuesday. Tuesday was not so hot. Some of us did awesome. So shout out to Isaiah, Chewy, Elder, Gracia, Brandon, Ezra, Mia. Y'all turned in on Tuesday and I appreciate you so much. We are missing 50% of the assignments. And so I wanted to show you something so that you could like for sure turn them in. So here's why. On the assignment, right? On the assignment itself, there are 7 videos. Notice you only had to do 9 problems. Most of us only had to do 9 problems. There are 7 videos, right? So 7 videos, 7 problems that are basically done for you. If you only did these 7, you would get a B on this assignment, right? So if you just did these 7 problems, you'd get a B. So like, even if you only did these 7, that'd be great. If you did 9, you can get an A. That's awesome. But I did want to show you that like there are so many videos for Tuesday because I know that the material was really hard on Tuesday, right? Dividing's hard. So thank you to those people who worked really hard. Some people even got a little bit of extra credit for the problems that they did. And I also wanted to show you, it's on the assignment itself, which you all probably really saw, but it is also on Canvas, right? So also on Canvas, if you're on the assignment page, I'm going to be putting a help box video right here. So you can actually see like I did number 1, number 2, number 3, number 4, number 5, number 6, and number 8, right? And so we want to make sure that you're able to like make that happen. Does that make sense? My people who did not, so shout out again, shout out to my people who did turn it in. If you didn't turn it in, can you just quickly let me know in the chat why not? You can just private message me. You don't have to tell everyone. Just say like you didn't get to it, or like something came up, or you got stuck, or you forgot. That's totally fine. If it's that you forgot to submit, I would encourage you to submit right now. If it's that you forgot to do it, that's okay. We can do it either today or tomorrow. If you didn't understand what to do, just let me know. Just like real quick, no hard feelings. Easy peasy. So shout out to my people who did do it. Thank you so much. Hi, Ari. I didn't see you sneak in here. Stephanie must have let you in. Cool. Okay, shout out again. Thank you so much for turning that in. Cool. Okay, let's jump in. We're going to jump into this notice wonder. This notice wonder. What do you notice about these? You could talk about the red one, the blue one, the green one, or the yellow one. What do you wonder? Is there something that you're wondering? Like, wait, why does it do that? And then which one doesn't belong? That could be a question that you answer, right? So which one is like different than all the other ones? So we have the red one. So I typed in this on Desmos and it told me the answer was 4. I typed in this on Desmos and it told me the answer was 1000. I typed in this, it gave me 4. Typed in this, it gave me 3. You can go ahead and hit enter on your noticings or wonderings. Yes, Alexia. 3 of them have the number 2 on top, right? They're squared. They're squared here for sure. That's a great noticing. Mia is noticing that they're all radicals. We have square root, square root, square root, cube root. That's awesome. What other things are we noticing? Brandon is wondering, why is the 2 on the other side? Like, why is it over here? We've been dealing with the little 2 right here. That's a great question. Why is there a 2 over here this time? Good question, Brandon. What else are we noticing or wondering? What color would you say doesn't belong? Yellow. Chewy, why yellow? Why does yellow not belong? Maybe the parentheses? Yeah, it looks different, right? There's parentheses on that one. There's no parentheses on the other ones. Yeah, I definitely agree. For sure. It's also, I would say, the only one that has a 3 on it, right? Like all these other ones, they have 2, 2, like just square root, square root, square root. This one's a cube root. It's a different one. For sure. Good noticings. Does anyone notice anything about this? I have square root of 4 squared is 4. Square root of 1000 squared is 1000. Square root of 3 squared is 3. What do you notice about these numbers? Even cube root of 4 cubed is 4. What do you notice about those numbers? Anybody got a noticing? Do we get the same numbers or different numbers? So like if I have a 4 here, my answer is 4. Do I get the same number? 4 and 4, 1000 and 1000? Do I get different? Yeah. Yeah, I get the same number. That's kind of weird, right? We have the square root and the square. They are opposites of each other. So they cancel each other out. The square root and the square cancel, and we get that number 1000. Same thing's happening here. Square root and square canceling each other. The 3 drops straight out. Same thing we have here. The square root and the square cancel each other, and we're left with just the 4. Right? Even the same thing is happening here. The cube root and the cube are canceling each other, and we have just the 4 coming straight out. We're going to use this strategy in order to solve some equations today, right? So we're going to use the same strategy to solve equations. And we will jump in today, okay? Let's go ahead and jump over to our notes. Let me ask you this. Do you have a paper, pencil, paper, pencil? Whoa, not that one. Stop. Don't answer that one. Hold on. Do you have paper, pencil? Are you ready to take notes? Let me know. All right, looks like 4 people are ready to go. I'm looking for some more answers on my poll. If you are ready to go, you can title your paper Solving Radical Equations. I got 6 answers. I'm looking for 6 more. All right. All right, my friends. There are 4 steps to solving this equation, right? 4 steps. It looks like 8 of us are now ready to go. It's looking good. I'm waiting on 2 more people. 2 more. No problem, Brian. Thanks for coming back. Sorry, your Wi-Fi tripping out. All right. Okay, so we have 4 steps to solving radical equations. We're going to write down these 4. You don't need to write down all the words. I'm going to highlight the words I want you to write down. So the first thing we're going to do is isolate the radical on one side of the equation. So isolate, right? Isolate. What does the word isolate mean? What's that word isolate mean? Yeah. Yeah, it means get by itself, right? It means get by itself, right? So it's kind of like quarantining. We want it to be by itself, right? We don't want it to interact with anything else. Okay. And then we're gonna, once we have it isolated, once we have it by itself, we're gonna raise it to a power, right? We're gonna raise it to a power. So basically, I mean, I'm gonna square it to eliminate the radical, right? So I'm gonna square it to get rid of it. So if I have a square root, I'm gonna square it. If I have a cube root, I'm gonna cube it. Like that. Then I'm gonna solve the equation, and then I'm gonna check the equation. I'm gonna solve it, and then I'm gonna check it. So I'm gonna isolate it, I'm gonna square it, I'm gonna solve it, and I'm gonna check it. Isolate, square, solve, check. All right. This is my first example here. Make sure you got number 1 written down on your paper. It is 2 square root x plus 2 plus 1 equals 7. So I have the things here. First thing I need to do is isolate it. So I need to get the square root by itself, right? I'm thinking about this like the same way I would think about 2x plus 1 equals 7. 2x plus 1 equals 7. What would I do first? If I was solving this orange equation over here, what would I do first? Feel free to come off mute if you're feeling fancy. Or tell me in the chat. If I was solving this equation, what would I do first? -7. I could -7, but that's going to clear everything from this side. So I don't want to do that. I want to do something else that's going to take away. I want to get x by itself. Yeah, so Alexia and Mia, I'm gonna subtract 1. Great job, right? So that would leave me with 2x equals 6. And then how would I get x by itself now? What I need to do? I have 2 times x. What would I need to do? Divide 2 from both sides. Absolutely. Yes. So I'd have x equals 3, like that. Right? This problem is exactly the same as this problem in the steps that I need to do. So I need to get x by itself over here. So I'm going to do the same thing that Mia and Alexia told me, which is subtract 1 on both sides. So everybody should be writing this part down. And I would have 2 square root x plus 2 equals 7 minus 1, which is 6. Then I want to get the square root by itself. So I need to get rid of the 2. So I'm going to divide by 2, divide by 2. And that gives me square root x plus 2 equals 3. Square root x plus 2. I'm not going to cancel these 2's right here, right? Because the square root has that locked in there. So I can't do anything with that. All right. Now, that was my first step. I'm going to isolate. I'm going to get the square root by itself. All right. Now, my second step is power, right? I'm going to take it to a power. So since this is a square root, the index here is 2. So the opposite of a square root is a square, right? So I'm going to square this whole side, and then I have to square this whole side. Whoa, not 3, 2. So the square root and the square, those are opposites of each other. And what I do on one side, I have to do on the other. So that's my second step, the power step. I'm going to take it to a power, to an exponent. All right. My third step is to solve it. So what happens is that a square root and a square will cancel and leave me with x plus 2 equals, what's 3 squared? 3 times 3. 9, yes. 9, like that. Then I'm going to go ahead and subtract 2 on both sides. I see plus 2. I need minus 2. So I get x equals 7. 9 minus 2 is 7. This is my answer. I'm going to use my calculator to check. So I'm going to use Desmos here. Use my calculator to check. The way that I'm going to check is I'm going to type this in my calculator. And instead of x, I'm going to put in the number 7. So I have 2 square root. Instead of x, I'm putting in 7 plus 2 plus 1. And I see that it does indeed equal 7, right? So that equals 7 there, which is true, right? So this is my answer. So the calculator is how I am checking my work. Right? How I'm checking my work. I will go ahead and drop in the best. I think this will work as a equation. So if you are also trying to like check your work today, I would use this calculator here. I'd use that Desmos calculator. That's how you're going to check. If you don't love that one, you can also use scientific. Desmos also has a scientific calculator, which is this one here. You can use either of those calculators to solve it. And in that way, it'll allow you to type it all in. You don't have to like do it by hand. which is great. Okay. So our first step was to get the x by itself. Our second step was to raise it to a power. Our third step was to solve it. And our fourth step was to check it on the calculator. Okay. Can you tell me, how are you feeling about this? We've done one so far, so we might be feeling good, might be feeling bad. How are you feeling about this question? Got 7 people voted. I'm looking for at least 9. Oh, got 9. Awesome. All right. So right now we have some 4s. We got some 3s, some 2s, and some 5s, but a lot of 4s. Cool. All right. Let's try a second one. All right. So we have our question number 2 right here. Square root of 2x minus 1 plus 5 equals 2. Square root 2x minus 1 plus 5 equals 2. All right, so we're going to isolate it first. Isolate, remember, means get it by itself. We're going to get this by itself. So what do I need to do if I want to get rid of plus 5? What do I need to do? What's the opposite of plus 5? Minus 5, for sure. Minus 5. So I have the square root of 2x minus 1 equals 2 minus 5 is negative 3. All right, so my isolate step is done. My isolate step is done because I have the square root equals a number. Right, so square root equals a number. My second step is a power. Right, I'm going to take something to the power. I have the square root. What's the opposite of a square root? The opposite of a square root is a square, yes. It's a square. The opposite of a square root is a square. So I'm going to square both sides. The opposite of a square root is a square, so I'm squaring both sides. The square root and the square will cancel. Leave me with 2x minus 1 equals, here I've got negative 3 squared is positive 9. Be careful that it's going to be positive. Notice if I just type in this negative 3 squared, it tells me negative 9, right? That's weird, right? But it's because I want to do negative 3 times negative 3. So I got to put it in parentheses like I did here, right? So not negative 3 squared like that, but negative 3 like this. All right. I want you to go ahead and solve the rest of this on your paper. Go ahead and continue solving. And then you should get one of these answers. One of these answers. You can go ahead and answer the poll. If you get A to be 5, B to be 3, C if you get 0, and D negative 1. All right, we've got 7 answers here. I'm going to go ahead and add 1 on both sides. I get 2x equals 10 divided by 2, divided by 2, x equals 5. X equals 5. So I got lots of people who chose 5. Good job to those of you who chose A as 5. However, we still need to check our problem, right? We still need to check our problem. So I'm going to go here, square root 2 parentheses 5. So the 2x minus 1, and then plus 5. It should give me 2. But notice here on the calculator how it gives me 8, right? So it should give me 2, but instead it gives me 8. That means that this is actually not a solution. This is what we call extraneous. It means that we did the math correctly, but when we plugged it back in, it doesn't work. Right? When we plug it back in, it doesn't work. It's actually kind of like this. So if we had 2x minus 1 plus 5, this part here, right? And then it equals 2. So I'm going to put in here y equals 2. Do you see how those lines never touch? See how we have this line over here, and then we have this line here, and they never touch each other. So because they don't touch, it actually doesn't have any solutions, right? It's very, very interesting. This one's actually called no solution. Kind of wild. Extraneous. Yeah, it is a funny word, right? I kind of think of it as like extra, right? Like this number is really extra and he's being annoying, right? So he doesn't count. It's extraneous, right? Or like it's an extra answer, but it's not an answer. So extraneous, if it does not check out, if it doesn't work when you check it, right? That means that it's no solution. Kind of interesting. Kind of interesting. While we were doing this problem, David asked me a really awesome question. David's question says, in other words, putting it in parentheses removes the radical sign. And I was like, yeah, if you have the parentheses and the square, right? The square is the opposite of the radical. So the square removes the radical. I love that. That was a great question. Great question and great thinking. Yeah. Okay, so we have 2 situations. Sometimes when we get the answer, it checks out and we get our answer correct. Sometimes we check our answer and it doesn't work out, right? And so that means that there is no solution. Okay, no solution. I want to show you one more example. I'm actually going to skip number 4, but we can do number 3 because I want to show you what happens when you have square roots on both sides. Right, so we're going to skip number 4, but we're going to do number 3. What is the opposite of a square root? What's the opposite of a square root? What would remove the square root sign? We can't divide it yet. We have to get rid of the square root sign first. How do I get rid of a square root? What's the opposite of a square root? We were just talking about it. How did I get rid of, what did I do over here to get rid of the square root? Power. Yeah, we're going to take it to that power of 2, right? The exponent. Absolutely, Joey. So since I have the square root here, I want to take it to the power of 2. And once I do that on one side, I also have to do on the other. So what's cool here is the square root and the square are going to cancel. Square root, square, cancel. Leaves me with 2x minus 1. Square root and square cancel. It leaves me with x plus 1, like that. X plus 1. So now I'm going to go ahead and solve this problem. I need to get the x's on one side. I have two x's here and one x here, so I need to move the one x over. So I'm going to subtract that x on both sides. I can even think of it as like subtracting one x. That's going to leave me with 2x minus 1x would just be x minus 1 equals positive 1. And then I want to get x by itself, so I'm going to get rid of this negative 1. I see minus 1, so I'm going to add 1 plus 1 on both sides. Leaves me with x equals 2. So before I do anything, though, I'm going to have to check square root 2 times 2 minus 1 equals that number, and square root of 2 plus 1 equals this number. And they should be equal to each other. So I put in the 2 here, put in the 2 here. They should be equal to each other. All right. So since they are equal, I know that this is the correct answer. I know there are probably some questions, right? What questions do we have? Do you have to plug it in to find out that if that's the actual answer? Yeah, you have to plug it in. So you're going to take this 2, plug it in right there, take this 2, plug it in right here, and see if they are the same. See if they're the same number. Yes. Yeah, Mia, I can. You have to use Desmos. You don't have to. If you wanted to do it in your, like, you could do it on paper. So let's say we had the square root of 2 times 2 minus 1, like that, is equal to the square root of 2 plus 1. This is 4 minus 1 would be the square root of 3 equals 2 plus 1 is 3. So you could do it by hand, Churi, if you wanted to. As long as this number equals that number, then this answer is good. It's a really good question. Yeah, Mia, for this part here, in order to get started, the problem is actually really similar. In order to get rid of a square root, we had to square it, right? And what I do on one side, I have to do on the other. So what happens, Mia, is that the square root and the square will cancel, and just the 2x minus 1 comes out. And then the square root and the square cancel, and the x plus 1 comes out. Right? And then from there, I'm just solving it. I moved the x over, and then I got x minus 1 equals 1, and then I added 1 on both sides. Got x plus 2, or x equals 2. Does that make sense? Mia, is that enough, or you want me to do it again? Good, okay. Okay, cool. Okay, my friends, for your homework today, I am going to make sure that we know how to do this. If you are doing these problems, so you have your paper version here, per usual, and then you have your IXL option if you want it. If you're doing the paper version, I'm going to let you skip number 5 and number 6, unless you want to do them, but because they have the cube root there. So number 5 and number 6, you can skip those. If you are on track, you're doing 10 of them, which I guess now is 8. If you are honors, you're doing 12, which I guess now is 10. So you're going to choose 10 of them if you're honors, or 8 of them if you're on track. What's cool about these problems, you're going to solve number 1 and solve number 2, and they're going to have the same answer. They're going to have the same answer, so you'll know that you did it correct. Right? And then number 3 and number 4, you'll solve those ones, and they'll have the same answer. Number 7 and 8 have the same answer, etc., etc. Right? Both of those continue on. Okay. From there, you have just 5 points for this one. You just have Maria did it this way and Lupita did it this way. One of them is right and one of them is wrong. Okay, so one of them is right, one of them is wrong. You're going to say who's correct, who's incorrect. Then you're going to try to find their mistake. What mistake did they make? It's worth only 5 points. If you're going to skip a section, you can skip this one. Right? And then part 3, as always, is your checkpoint, your Google form. Okay, checkpoint Google form. If you want to work on this assignment together or with Stephanie, I'm going to go ahead and open up this room. You can work with Steph on these questions together. If you're feeling like a 2 or a 3, right? If you're feeling like a 2 or a 3, it might be a good idea to check in and take that breakout room. Okay. If you are feeling really, really strong, then you can go ahead and work on it on your own. Otherwise, I will see you on next Tuesday. See you on next Tuesday, or I'll see you tomorrow if you have office hours. All right. All right. Bye, my friends. Have a good day. Have a good day. Pop into that breakout room. Elder, Lauren, Chelsea, pop into that breakout room. Hi, Lily. Lily, we're going to take a break, so we'll be back in like 10 minutes.